All right, this is part 3 of our look at quadratic equations and their graphs, and I've got an example written up here already, which is to graph y equals negative a half x minus 3 squared plus 2. So to create our graph, we're going to start off by identifying exactly where is the vertex. That kind of gives us a real good foothold. Now the trick is, where does this become 0? And that's at 3. And if we plug that into our function here, we're going to get 3 minus 3, 0 squared, which is 0 times negative a half, also 0 plus 2. So there's our vertex. Now, after that, it's probably best to find the x-intercepts. The y-intercept isn't quite as important, but it's an easy one to get, so we might want to do that too, but definitely the x-intercept. So we're going to put in a y value of 0, and then go ahead and solve the remaining equation. Okay, so negative 1/2, and then we've got our x minus 3 squared plus 2. Okay, so now in my solving, I think we're going to subtract 2 to the other side, leaving us with negative 1/2. Whoop, that got smudged. X minus 3 squared. And then I'm going to multiply to get rid of this fraction here. I'm going to multiply both sides by negative 2. And that's going to turn this into positive 4. And it's conveniently, it's going to get rid of this negative fraction here. So I'm left with x minus 3 squared. I'll just pull things down a little bit more here. And now I'm going to square root both sides. So when I square root, I do exactly the same thing on both sides. And of course, you have to make this plus and minus. So this is going to be plus and minus 2. And over here, you got no more square root. So just the x minus 3. And lastly, I'm going to add the 3 over to this side. So we have 3 plus or minus 2, which equals x. So where are those x-intercepts? Let's work them out here. On the one hand, you have 3 plus 2, and on the other hand, you have 3 minus 2. So I'm just going to write them as actual points. One is the point 5, and of course the y value is 0. And the other one has the coordinate of 1 and 0. So I've got my x-intercepts. That looks pretty good. I've got my vertex. So I think I'm all set to produce a graph. So I'm just going to pull the grid, move the page down a little bit. And then we're going to paste in a grid and work with that. So let's paste it in. Okay, there's our grid. And let's plot our points. So the vertex we had was at 3 and up 2. So it's up here. And we have the x-intercepts at 1 and at 5. Now you can see this parabola is different from ones we've done previously because it opens down. So I know I got this kind of a shape going here. So up to the vertex and then down through that x-intercept. So I know this side here is just roaring down. And I know this side here is roaring down, but there's one last point might be of interest, and that is where are we crossing on the y-axis. So if you recall, if we just pull it up here, there's our function. And what I'm going to do is I'm going to put in where the x is, I'm going to put in 0. So it's going to look like this. The y value is going to equal negative 1/2. And now I'm going to replace x with 0. Whoops. Don't want that. If we can get, oops, took everything away. Okay, we'll just pick it up where it was. So y equals negative 1/2. And we're going to replace the x with 0, and then we have minus 3 all squared plus 2. Now, if I just work that out, this is going to be negative 1/2 times, now this is negative 3 squared, so that's going to be 9 plus 2. And so probably easier if I just change this to a decimal. Negative 1/2 times 9, negative 4.5. plus 2. So I've got the y-intercept now at negative 2.5. And that just tells me here I want to be crossing down here at negative 2.5. So graph actually goes a little bit wider than I had drawn it there. Okay, now there's our vertex. We also have our axis of symmetry is this line here. Just sort of sketch that out. And the equation for the axis of symmetry is x equals 3. What else do we want to identify? Maybe just the domain and the range. We'll put that over here. The domain of this is like most parabolas we're going to look at. It's all x's. And the range, a little more interesting, it seems to have a high point or a maximum here at 2. So we're going to say, well, the y values all appear to be less than or equal to 2. And there you have it, a parabola that opens down.